Almond Springs, and some issues regarding flow and declines of flow, and we'd like to just keep it happening. So let's move on. We start off with a map. Steve showed this pretty much the same map. I want to focus on a few geographic points. Balmorhea and the San Solomon Springs are shown in the symbol down here. This is Jeff Davis, Culberson, Reeves County. We've got some structures. We'll talk about the Stocks Fault, and then some folds that are referred to as the Roundsville Folds. Wild Horse Flat off to the west, Salt Basin up here, Van Horn is right over here. And then the boundaries of several aquifers that we'll talk about as I proceed here. So one of the things that Mauricio, who is with Southwest Research Institute, who's part of the working group also, was planning to present is the history. And I'm a geologist, I'm not a historian. This is pretty much the summary of what I can get to you. Native Americans probably channelized some of the flow. That was pretty common, not just at San Solomon Springs, but on the Rio Grande, the Pecos too. They were referred to as Mescalero Springs by 1849, and then San Solomon Springs later after that. The CCC came in the 1930s and built a lot of that structure that you see if you go swimming there at the springs. And then the springs were dredged in 49 by the Bureau of Reclamation. And all of the history basically that I could find in a quick survey came from a Texas Parks and Wildlife Department website. So we all know as much history of San Solomon Springs now as I do, and as apparently as they do. Now, what I can tell you a lot more about is the geology. So this is thought to be a pretty large regional flow system. So the geologic background requires going back pretty far in time. First off, we have to be aware that cropping out to the west near Van Horn are 1.3 billion year old Precambrian rocks. These are the result of the Grenville orogeny, a mountain building event that predated the later Marathon Ouachita orogeny that also affected this part of the world. But the Precambrian rocks were part of the Grenville. You can find those in the Wiley, Carrizo Beach, and Baylor Mountains, and those are on my air photo here. Wiley is over here, southeast of Van Horn. Carrizo are over here, just south of the interstate. Beach and Baylor are both right up there north of Van Horn. The lithologies that are there are metamorphosed metarhyolites. There are pegmatites, there's mica schist, there's amphibolite with garnets. I used to take my field camp class there, south of Van Horn to map. It's just a fascinating place to see Precambrian rocks. And if I could put a plug in for Sul-Ross geology, a long time ago in 1980s, Roberta Rudnick got her master's thesis at Sul-Ross studying those rhyolites and using geochemistry to interpret them to be remnants of island arcs that were part of a pre-earlier geologic system. Roberta Rudnick is currently a member of the National Academy of Sciences, and that's a pretty elite group. And we have Sul-Ross as a graduate who studied these rocks, who went on to fame and hopefully fortune as a member of the National Academy. Next on the list, Steve talked about this, the Paleozoic rocks. Mostly we're going to focus on the Permian. A little bit of it is a little bit older. It includes the Capitan Reef and the Delaware Basin and the Delaware Mountain Group. So basically, it's as Steve described, it's a reef system that was Permian in age with a sort of deeper section in the middle, very important in oil and gas. That's the Delaware Mountain or the Delaware Basin. And then as that Permian system began to basically got cut off from the open ocean, it ultimately became a sequence of evaporites, which are the Castile and the Rustler that we talked about, that Steve has talked about. I've got a little bit of detail to add to this. Now, wait a minute. I don't know what that is. Not supposed to be there. There we go. Another one of my former field camp sites, I would take students to the Guadalupe Mountains and hike the reef trail. So if you want to go see what a reef looks like, basically in cross section, the reef at the Guadalupe Mountains area looks roughly like this. It sort of prograded up as sea level changed or basin levels subsided. And you have back reef deposits, reef, and then the deep basin stuff there. That's basically the classic structure of the Permian Reef. And if you go to the geology trail, which has a trail guide, which I've screen captured the cover of it. There's a trail that allows you to hike from the deep ocean, basically through some slump blocks up to the reef and to the back reef. So basically, the thing that's interesting to me about that the Guadalupe Mountains and that reef trail is that it is a reef that is fossilized, but then faulted up and exposed into its living position without the water. So basically, that escarpment at the Guadalupe Mountains is not a fault scarp; it's a natural reef morphology scarp, basically. And the other thing I want to point out, that's what this is down here. To see the reef, all you have to do is go out the door of the Sul Ross campus and look east, and the Capitan is exposed right over there. Steve showed that map that has the reef coming down here into Brewster County. I live 10 miles south of town. I can go out my back door and look, and I can see Capitan, Word, Cathedral Mountain, all these formations that are part of that Permian. So it is down here also. And it's very close to home to those of us in Alpine. Okay, later this was the geology was the shallow inland sea that extended from Texas to Alaska, part of the Mesozoic system, that formed the rocks that we refer to as Edward Trinity, either plateau or high plains. Mostly the plateau version is what we are interested in here. Carbonate rocks, maybe a lot of karst in that is on top of that Permian system. That is then followed by volcanism that's mostly in the Davis Mountains, but the Trans-Pecos magmatic province essentially extended from 48 to 17 million years, but the Davis Mountains are mostly in the 30 to 40 million years. They're pretty important part of our hydrogeology study for San Solomon Springs. After that, the salt basin associated with the Rio Grande Rift began to form maybe 25 million years ago and continued, and then the Pecos Valley Aquifer. So I have a couple of things about that sequence. Myself and John White, Shannon Radine, Don Parker, Gary Henderson, ran the Geological Society of America field trip last fall associated with the national meeting in San Antonio. We had two of them, actually. Dr. Kelsher and I were part of the South one, and then these guys and me were part of the North one. But the point here is that mostly when we talk about San Solomon Springs, in a moment, I'll tell you that there's a contribution of flow from the Davis Mountains, and we just generically refer to it as igneous. Well, we know a lot more about that, actually. It's more than just one igneous unit. In fact, that cross-section is from that report, and it's actually a redo of an older cross-section. We're updating the stratigraphy. And Don Parker, among others, has been one of the ones who's done the most work on the volcanics. And I think it's important that we understand what that stratigraphy is. And one other thing is we also are famous globally for having the world's largest pantellurite, ignimbrite. What is it? Pantelluritic ignimbrite. So nobody knows what a pantellurite is, but we have the largest one. So there you go. If you've been to KC Ranch, which is one of the ranches that we have access for monitoring this flow system, their ranch headquarters is made out of this rock. It's a flow-banded, blue-green, beautiful rhyolite that looks like this. They have a whole headquarters that's made out of that. So now if you get to visit KC, you can be proud of the fact that Texas has the world's largest pantellurite. And it may contribute to recharge. There's springs right there coming out of that rock. It's the Gomez Tuff, by the way, which is one of the volcanic units that's primarily exposed on the northern Davis Mountains. If we move forward to the Salt Basin, we're moving forward in time. This is one of those oblique views from Google Earth. So up here, the Guadalupe Mountains, that escarpment is a natural reef front that is not a fault. The Delaware Basin's out here. The fault that uplifted the Delaware or the Guadalupe Mountains is along here and here that forms the Salt Basin. And it might be kind of a half graben. I'm not exactly sure how the structure of that is, but regardless, the escarpment that's visible that you see, and by the way, Carlsbad Caverns is dissolved right in the main facies of the reef itself. And that's right up in here. So again, that's that natural formation of the reef that is in place, except doesn't have all the water up to the top. Delaware Basin, the Apache Mountains are right down here. The Salt Basin extends way down all the way, kind of splits all the way down to Van Horn. All of that's really important for our groundwater flow interpretations, because some of the flow that makes it over to Balmorhea may be starting over here. And I'll explain why we think that here in a moment. So that's the salt basin and the geography. And now let's look at the springs themselves. First, the complex EDF put together a nice story map. You can Google that one. It's pretty interesting to read through there. But what one of the things you can get from it is that where the locations of Phantom Lake, San Solomon, Giffen, Saragossa, and Sandia Springs, all of this relative to Balmorhea, it's all in that vicinity. Phantom Lake is maybe I'd say San Solomon's the most well-known one because that's the source for the pools at Balmorhea. But Phantom Lake is where the cave divers have not found the end and the bottom. So there's cave diving and karst systems off to the west against the current that's coming from the west. So that's a small local indicator of what's going on. Also, in general, in the 40s, a report we'll see about here in a minute suggested a flow of about 50 cubic feet per second. Currently, it's 20 or 30. Steve mentioned that maybe, well, first off, that there is a long-term decline implied by that. Nico and others recently gave us a graph of some of this, and you can see these declines that have happened over time. So what is the reason for that decline is something that we're really concerned about. And Steve has already kind of told us that maybe it's just draining, or maybe there's some other impacts. In general, kind of okay. So take home points here is a gradual decline since the 40s or whenever, and that the TDS is in that 2,000 to 2,400 milligrams per liter, sort of brackish range. So it's definitely, that's not rainfall off the Davis Mountains, clearly. So there's some interpretations to be made based upon the water chemistry, the basic geology I'm going to talk about here in a minute, and basically our understanding of how the hydrogeology of the system works. So just basic cation-anion balances, the standard Piper diagram here, the Davis Mountains flow, the springs and the water from the Davis Mountains plot in the Piper in this region. Our springs and the Apache Mountain wells plot about right here. And then the Delaware Mountains are a little bit off. So basically we can't blame the Delawares completely for this flow or attribute it for that flow. One of the things that's not on this graph that commonly you do see are diameter circles based on TDS. If those were there, you'd have big circles up here in the Delaware. You'd have medium or 2,000 milligram per liter circles here, and these would be tiny because the TDS of the water coming off the Davis Mountains is pretty low. I stuck this on here. You can't read it, but this is explaining all those regions in there. The Groundwater Project is a United Nations funded project where you can learn a lot about groundwater. We're going to mention Matt Uliana here in a minute. Matt is currently active in Australia or New Zealand, one or the other, but he wrote a textbook that's online and free open source for hydrogeology that I'm using for my class this semester. It's actually pretty good. And being this link of hydrogeologic information, as you read through the text, there's links to other open source topics that are related. So you can just click your way through this. It's a pretty good hydrogeologic educational resource. So now if we look at kind of the history of people, science, literature that's been produced for San Solomon Springs, we can go back to White and others in 41, describe these artesian springs. They're the ones that measured that 50 or so CFS. And they attribute it to Cretaceous limestones kind of to the south and west of where Balmorhea is. But they also mentioned that, okay, so the springs they're Star Mountain. Springs are here. And then they knew these structures were over here, but there's also this little place that's called San Martin. They implied that maybe it might have recharged as far away as that and then flowed and kind of curved around and up. So that was the first report. They missed the scope. We think today, we'll see in a minute, it's much farther to the west, but they did get the right idea, but they mostly thought it was pretty much local recharge. If we move forward, Nielsen and Sharp, Jack Sharp is really maybe the one we can attribute most of the more modern stuff to, Jack or his students. So Nielsen and Sharp did a report and suggested that the Apache Mountains might serve as a conduit from water that recharged or is maybe coming from the Wild Horse Basin, which is just over north and east of Van Horn. They built a groundwater model and modeled how much water could come out, and they were pretty much limited to only about 3 or 4 CFS, which is not enough to explain all of the flow. But that was just the one model that is available in the literature that's not part of maybe one of the GAMs at the moment. So that kind of got us started there. Lefebvre and Sharp in 1987 made the connection of that 2,000 milligrams per liter to maybe some Capitan Reef lithologies and wells in the Apache Mountains to the west. So now what we're doing is extending our interpretation of where that flow path comes from a bit farther west. And then Sharp in 89, and he's got several papers through here that are all similar, suggests a Permian Reef and back reef in the shelf margin. As Steve said, in the Apaches, the reef itself is above the water table, but the back reef may not be, and in fact isn't. So Jack kind of gives us the chance to start thinking about it, maybe not right through the main axis of the Apaches, lower or south, or possibly north, because the Stalks Fault is over there too. So the Apaches are key, but understanding that structure is also key, and we don't understand it yet, I don't think. Uliana and Sharp used cation and anion geochemistry and some flow path modeling, looking at how water interacts with ground, modeling how it does that. And they came up with the modern idea is that the main base flow component, the main base flow component is a high TDS, 2,000, 2,400 milligrams per liter, something like that, sodium chloride sulfate from regional flow system that originates in the salt basin, which we saw that picture. The salt basin is over here, and it's tall, north-south. So where in the salt basin is now kind of part of the problem to interpret. But then that leaks over into the Apaches or along the Stalks Fault, which is right on the north of the Apaches, or south where the reef stuff is, the platform back reef stuff is. And then as it moves, then it mixes with lower TDS waters that are coming from the Davis Mountains, the spring flow from the Gomez Tuff. Especially when it rains, local precipitation can cause changes in chemistry at the springs within days, and turbidity goes up and then back down. So there's quick recharge from the Davis Mountains that's low TDS that adds to that basic regional base flow that comes from the west. Chowdhury and others did some geochemistry here. One of the things that Mauricio is going to charge with doing is talk about isotope geochemistry. I love talking about isotope geochemistry, so here we go. So what they started with is stable isotopes. So isotopes of hydrogen and of oxygen. They're stable. They have a mass difference, and when water changes phase from liquid to vapor and back, the ratios of those isotopes change because of there's a mass dependent fractionation associated with that. So basically every time water evaporates from the ocean basin or a lake or something, the isotopes become lighter. The lighter ones go into the vapor, and basically this line here, this is Del O18, oxygen and hydrogen on that other side. This global meteoric line, water line is basically how water behaves around the world as a function of that mass fractionation. So if your ocean is up here, every time water evaporates, it steps down the line. If it rains, the vapor steps a little further down the line. So basically you expect meteoric rainwater to be somewhere along that line, but if it's modern and rained yesterday, it's going to be pretty far up near 0, 0. And what we find in the waters from San Solomon Springs complexes are way, way down the line. They're very light isotopically, lighter than the Davis Mountains and lighter than, well, some of the others that I have some data for. So what that implies is they have a different, maybe a different precipitate or a recharge timing, really. The idea is that the recharge to produce that light isotopic values occurred maybe in the Pleistocene when the climate was cooler and wetter, when that stepping down the line was more consistent and farther down the line. So the stable isotopes imply old water. Basically, that's the idea. I have some data, by the way, that's not on this graph, and I haven't plotted it with the San Solomon stuff, but On my data, the Delaware, the springs in the Devils River area are farther up. The springs along the Pecos step down a little bit. The springs in the lower canyon step down a little farther, and depending on whether you're up and down, they step farther. And then some springs we have from the Guadalupes are even farther down, kind of like this. So there may be more to that story that's geographically, spatially distributed out here. But right now, for the purpose of this talk, the light isotopes suggest old water recharged during the Pleistocene. Now, let's move on. So the next part of the isotopic story is radiogenic strontium, strontium 8786. I borrowed some graphics from my igneous petrology class, which I'm teaching this semester also. I don't see any of my students in here to help me, but basically the radiogenic strontium story requires that you know that the radioactive isotope rubidium 87 decays to 87 strontium with a little beta decay thing going on there. We can ignore that, but basically the point is that the Earth's mantle melts and produces crustal rock, and that rock gets caught up in hydrologic systems, and rubidium gets moved and concentrated in stuff. And basically the bottom line is the mantle sits at a ratio of 704. And a long time ago, if you extracted some crust, maybe Roberta Rudnick's metarhyolites or something, and let that stuff interact with the hydrologic cycle, basically rubidium gets moved around and concentrated. And if you do that a long time ago, you get enough rubidium to cause the crust to evolve to a different strontium 87-86 ratio than what you started with. Now, I'll apologize. The geochemists use these weird 704, 705 numbers like that. It's just the way we analyze it. But the rocks that we're going to talk about might have a contribution to San Solomon Springs started off at 704, but rubidium got concentrated a long time ago, maybe 1.3 billion years ago, and gradually it decayed to a higher value of 8786, maybe 0.71 or something like that. So we start at 704, but now the rocks at Van Horn have values in that 0.71 or so range. So if you let water fall on an old rock, then that water might inherit some of that strontium. Groundwater doesn't have a lot of strontium, but there's enough to measure. Jay Banner at UT, if you know, was part of this. He was on the team. He recently did a similar study in Austin that I saw at the TAG meeting last fall, where he's looking at strontium 87-86 ratios in tree roots in urban Austin versus rural. And the urban ones have higher 87-86 ratios because of leaky distribution pipes. It's municipal water and irrigation for lawns and all that stuff. So it's actually, in that case, that water's coming from somewhere else, and it's part of the water distribution, municipal water supply that's changing the base flow in Austin. Here, he helped to interpret and use the high values of strontium to say this recharge had to have fallen on old rocks with a lot of rubidium 87 that decayed to the strontium 87-86. And I have a map here to show that. So San Solomon Springs have a high 87-86 ratio. And the only place you can get that is way over there at Van Horn. Remember, we talked about the Carrizo and the Wiley and the Beach Mountains. That's where those old metarhyolites and stuff with the strontium, with the high strontium 87-86 ratio, because they had that they're old and they had that concentration of rubidium. So what we see is values that are approaching 0.71. And that doesn't sound much different than 704, mostly to somebody, but that to the isotope geochemist, that's a huge difference. And they could actually contour those 87-86 ratios from water in wells and suggest a flow path like that. This is where we need more data. We need more wells. We need more numbers to see if we can't fine tune this. But basically, I'm kind of happy to see that, because I'm kind of in the camp that thinks it's Apache Mountains and south, maybe. The water might be flowing right under I-10, going from west to east, because that's right there. So there's a lot of different data supporting flow from the west, stable isotopes, cation anions, radiogenic isotopes, and that's pretty strong evidence there because there is only one place to find that isotopic signature, and that's from way over there to the west. Later, Nunu and Green, Rebecca Nunu was at UTSA and then later worked with Edwards Aquifer and Sweary. Her thesis was to use principal components, a statistical technique to pull out statistical trends and identify components. So she came up with four. One of them is the regional flow that we've already talked about that might be coming from the west in Permian rocks, but maybe in Edwards Trinity also, could be in both. So that's that regional base flow that everyone else has talked about. She's got infiltration through Cenozoic Pecos alluvium that might be irrigation return flow, local. The Saragossa Springs, another irrigation precip signature, and then the local precipitation off the Davis Mountains. So the one thing that Rebecca added would be this irrigation return flow component that might be part of the contribution to the springs. And then Nico and others at the Bureau of Economic Geology came up with a 20 to 30 CFS flow, summarized and concluded the same as others had said, is that there's that big kind of major base flow from the west, which would be right along here. They also suggest maybe some recharge from the northern end of the Salt Basin, west of the Delaware Mountains. And then also from Wild Horse Flats. This would be where Jack Sharp, Nielsen and Sharp had that idea going into the Apaches. So geochemical signature of the brackish component could be from evaporitic Castile and Permian Reef and back reef facies. None of that's really new, but the idea of this flow path from up here is kind of new in terms of the whole sequence. I'm not sure anyone else had suggested that. And then clearly the flow off the Davis Mountains too. But, bottom line is the main flow is from the west. This is a significant regional flow system that needs further work. They did come up with kind of a flow chart that's kind of puts boxes around the components. We got Salt Basin North, the reef, the South Bolsones. By the way, the Bolsone term is the basin, the faulted valley that's there. The Castile, the platform, the reef in the Apaches, maybe some cross-formational flow into the Edwards Trinity, the igneous contributing for sure as you get closer to the outflow of the springs, maybe Rustler, Davis, Delaware Mountain Group, no connection apparently, and then the Pecos Valley alluvium contributions too. So it's a pretty complicated system there. Our own Steve Finch kind of put a geologic context to this, which not that anyone ignored it, but he kind of goes back to making some cross sections and seeing that things make sense. And he already mentioned this. Here's your water level and the Capitan Reef in this one particular cross section, which is, by the way, across the Apache Mountains, suggests that the reef itself is not the water-bearing unit, but maybe some of the shelf deposits, and then we got Cretaceous up on top back there too. So going back to looking at the bedrock geology is important. And that's one of the things that we're really trying to do. We're trying to gain access to some properties we haven't had access to before, measure levels, measure water, carefully measure elevations. Because when you go measure a water level, you're measuring down from your top of casing or whatever the interpretation of the elevation is at the surface, and we're trying to refine that to make sure we know what those elevations are, all based upon the same datum. Here's Steve implied that maybe there's a need to redefine where that Capitan Reef complex is, because this is the map version from the Water Development Board. But Steve's firm believes that the reef and the system should be a little bit larger. Those are saturated thickness in the reef and back reef deposits, and there's the interstate. So, that supports that idea that maybe some of that flow, if it is from Van Horn, is Apaches or south. but again, you can't forget that that Stocks Fault is up on the north side. It's not on this map, but it's there. And that syncline anticline structure that's Roundsville that goes right through the KC is also part of the story. So a summary here is all the modern studies suggest a regional base flow to the springs originating somewhere to the west with flow through or near the Apache Mountains. Water chemistry is sort of brackish, 2,000 to 2,400 milligrams per liter, probably due to interaction with evaporitic rocks of the Delaware Mountain Group or the Permian Reef, which is, it should include that there. The radiogenic isotope data suggests interaction with old Precambrian rocks, so we got to have some of it coming from west out there by Van Horn. And then the stable isotopes suggest a cooler, recharging a cooler, wetter climate. So is it currently recharging then is another question. So various authors suggest flow from portions of the Salt Basin, north or south. Limited modeling suggests only a little bit of it can come from Wild Horse, but that could sure be looked at again. Bedrock geologic studies and water level elevations suggest the flow may be either north or south of the Apache Mountains. And then the Stocks Fault right there. And then the syncline, anticline structures there are pretty important. Our Dr. Kels here, who is part of the Meadows Research Institute, is a structural geologist, and we're going to start looking at fracture patterns and trying to relate structures to groundwater flow. And we believe this, Steve and I think, believe that much of the flow is further south of the Apaches via, based on level information that he's measured, and those strontium isotopes suggest that it's south, maybe even as far south as the vicinity of I-10. The other things we'd like to know, we need more information on levels. We have a good relationship with the KC Ranch, so we're right here. But we need, and Cody Bjornson has got some water development board wells he's measuring that are right up in here. We'd love to have some more over here. The more the better. The issue is the landowner, issues. Private property is big in Texas, and some of them don't want people to know. And so we're just in a communication, hopefully productive communication with many of them to try to gain access to measure levels, maybe do some monitoring, some telemetry stuff so we can get some longer term data. So that's kind of what we're looking for. And the KC Ranch has been really cooperative, Paul Foster, so far. And we have Texas Pacific Lands that owns a lot of checkerboard pieces out there that we may gain some access from too. So I think that's it. Before I stop, I want to go back to one thing I didn't say back here. Is this that when we were talking about the tertiary, the volcanics, that cross section is immediately east of Balmorhea. So that one's very close. So if you drive that road from Fort Davis up to Balmorhea, you drive right up this valley. If you've noticed it, there's a big syncline there. And that's where that is. So anyway, that's my summary of San Solomon Springs. And I don't know, I probably went too fast. 10:30. Yeah. Jesse.
So, the water announcements themselves potentially a recharge zone manufactured enough, so maybe something upstream of that.
You should ask Steve that, but yes, I think he'll say yes. Right, and that would be here. Right? Yes. That's because this is on. Yeah.
concept that looking at older as part of the concept or equation of the sea and the category. What we look at something more structurally modern instead of looking at an older time. How about a more recent elevation?
Mm-hmm. Mm-hmm.
Next, there was the a good location. That modern. They started in the brain and reaches. I don't know if that's something that.
Well, you know, I think that what I said about the data I have might be more like what you're saying, because I see, and I'm going to draw on this graph, not remembering exactly where the springs on the Devils and then the Pecos, but basically I see a east to west decline down the line in springs from the Edwards Trinity Plateau Aquifer and the Devils to the Pecos to the lower canyons. And then even within the lower canyons, I see that spatial, excuse me, because they're 70 miles or so long, 80. And then even further down the line from springs in the Guadalupes, which are not Edwards Trinity. But maybe that implies a more modern spatial distribution that's related to the fractionation associated with the modern meteorological cycle. So I don't know. I think that supports what you're saying. But if we have the strontium isotopes are correct, then we still have to have that water coming from west to east. How long would it take? And could we model that? How long would it take for water at whatever velocities that you could model in a karst or not karst system? So there's that could be done. I haven't done it, but that's a pretty long flow path. So it's not out of the question that the isotope data might be correct, that it was a long time ago. And by the way, this is part of that overall, if you've seen it, let me see if I have, no, wait. No, I need that name. Just hang on a second here. There. Some of you, I'm sure, are familiar with Jack Sharp's. When he first came up with the regional flow path, he had stuff coming from as far away as Valentine. And starting, it won't be on this graph, but on this scale, he had the idea that you'd have flow coming up through Lobo before pre-development, maybe coming up through there into Wild Horse and then moving over here. So that even gives that idea that it could be really old water more credence, I think, if it goes that far back. I think that we know today the pumping in Lobo that's definitely a pre-development idea, not today. But there's the potential for some pretty long flow paths feeding San Solomon Springs. I don't know.
Thanks, Kevin.
Yeah. It is not on here. Those are the structures from the Geologic Atlas of Texas, so likely it would be on there. Isn't it north-south along the Delawares? Yeah, yeah. Tell Jesse to look at that. The border fault zone. You know, while we're tossing out terms like that, the Texas lineament is part of this too. Maybe right along the Stocks Fault, I'm not exactly sure, but that is kind of splits the salt basin too. Probably. Is it the blue?
That's because the wrestler out top in purple all north of the Capitan.
Here?
Yes.
Yeah. Yes. Nico and others say maybe. As far as I know, they're the only ones that have said much about putting that in there. The Chowdhury that had Robert Mace and Chowdhury, they said the TDS, I believe they're the ones that said the TDS was a little too high. But you were saying it's not that high, so or Castile anyway, may not be. There's a lot of information out there. Yeah. Jesse. Okay, the San Solomon Springs Collaborative is a working group. We're meeting, what, April 7th, I think it is. Yeah. And we're a collaboration of researchers and landowners. We're trying to attract as many landowners as we can to see why they may want to allow us to have access. We have Vanessa Pugh Williams from Environmental Defense and Christy Muse and others. I don't know who else, but Mauricio is part of it. So we're a pretty functional group. Dixon Water Foundation provided some money for research that's going through the EDF, actually back to me to put in to continue the research. They funded this work, but to continue the search and to go negotiate with landowners and visit wells and try to find more access to monitor for water chemistry and flow. So yeah, the San Solomon Springs Collaborative. Yeah. It's off.